Well, good afternoon or good evening, depending on what your clocks are set at. Thank you for coming and joining us today. I know this might be the first day of Jfokus, but for many of you, it's probably the second day if you were here on Monday for the workshops. We are honored to have you join the Ask the Experts panel. And while this might be familiar for many of you, let's just recap why we do this. This has been a staple session here at Jfokus, I think now for, if I'm doing the math correctly, 12 years consecutively, maybe 13. I'll have to go back and check. But the reason why we do this is while there's many sessions you'll experience over 2 days, presenters conveying a lot of Java knowledge and information for you to take away, we also want to bring the hallway track experience to all of you. Oftentimes we don't get a chance to ask questions in sessions, and so we wanted the format of a panel like this is for all of you to share your questions. And what we did was, in advance, we asked on social for all of you, as many of you, to provide us questions that we can ask today. And we've compiled quite a list. I'm not sure we'll get through all 49 questions. That's quite a bit to do in 50 minutes, but we're going to try and address as many as we can. But if we don't cover some of the questions that you may have posted or are currently posting, we do have a hashtag there. And if we can get to some of those, if you post them to Twitter, we'll try to get them asked. Please visit us in the Oracle booth, both tonight, especially in the reception, or come by and stop by tomorrow. Many of us will be there and we'll try to answer them as best we can. And so today's panel session, we are very lucky to have 4 of the leading minds on the Java team. George Saab, who actually runs the Java engineering organization, used to actually be based here in Sweden. One of the first people to actually start working on Java. I'm not going to date any of us. We have Chad Arimura, who runs our Java Developer Relations Outreach program. We have Per as well, who's also based in Sweden. And Victor, where are you coming from today, Victor?
I'm actually coming from southern Sweden.
Southern Sweden. So it's quite the group of experts we have today. And so this morning you may have heard George present on a very broad spectrum of why Oracle continues to invest in Java, how we invest in Java, why we invest in Java, and what direction that's going in. And so I thought it would probably be good to kind of recap some of that with some of the questions. And I'm probably looking at you to take this first question on. But, and by the way, all the panelists, you are welcome to chime in. This is supposed to be a conversational format, so if you have thoughts to inject, we try to keep this as open as we can. But George, according to you, the most important Java language feature introduced in the latest years, what comes to mind? This morning you showed a slide of many features since Java 11, but what's some of the ones that really stand out that this audience should care about?
That is a hard one because everyone has their favorite features.
But what's yours?
Well, what I like is the fact that we have so many of them and they're coming so rapidly, incrementally. That's a little bit of a cop-out, but that's what I'm going to say. No, I would say, of things that have come recently, obviously, there's some very visible things like virtual threads. I like the way we've managed to do things like introduce pattern matching all the way sort of throughout the Java language. And not only pattern matching, but things that work very well with it, like records and other, sort of ideas for immutable data and streams, right, building on lambdas. So this, that's sort of a neat trick to have started to do, because in the old days we would have, probably sat and thought for years and years and years about how to get this exactly right before we released any of it, and then it would be a huge impactful change that would be hard to adopt. So I'll go with that.
Okay, but for some of you who are working on specific features, what are some of the uniqueness of what's been produced in the pipeline of features over the last few years?
I think the records are a really good thing that we are able to build on. I'm working a lot with Panama, form function and memory API, and we see that we can actually use the nominal tuples there in a really intuitive and good way. And I think Victor has another comment on this.
Yeah, I don't want to cop out and say records too, so I'll have to come up with something. One thing that I use very frequently is method local classes. So being able to define a class inside a method and just model things without having to expose it in in the full type. So
That's a very small but useful. That's a very small but very useful thing that keeps everything local. Yeah.
I actually also had records in my mind on my list, but I'm personally really excited about a lot of the things being delivered as part of the paving the on-ramp stuff that we've talked about. Victor had some slides on it. George had some slides on it. And in paving the on-ramp is all about making the language more approachable for students and learners, and also just easier to write code for people who are writing scripting, like little scripts. And there's also, which is related, but the multi-file source code launcher, where you can literally, you can just type Java, then the name of your Java file, and we'll compile and run it. And now it will actually, check which references it makes to other classes and also compile those into memory. And so it just makes it so much cleaner for somebody the experience without having to set up something like, an advanced build system, which learners just, their eyes gloss over at the amount of XML to do that. So those are really exciting features that we continue to deliver on for new learners.
So, but in terms of paving the on-ramp, if we look at Project Amber, what really is the ethos of what Amber represents? I'm looking to you, Chad.
Well, I also really like a lot, as a developer, Project Amber is really exciting for me because it's all about making the language more concise, more expressive, to be able to really model what's in your head in code, move the language forward. And particularly one thing that we've been talking about is this notion of data-oriented programming. And so, our programs are getting smaller and they're interfacing with data, from the outside, like JSON or unstructured data, or just hitting an API and grabbing data, pulling it in, doing some transformation on it, and then pushing it somewhere else. And so rather than having this big monolith which pulls data into the object model and then you're doing whatever you want, paving the on-ramp is about delivering features like records and pattern matching, algebraic data types, which you had a great part in your presentation today, to make it a lot easier to write those programs and to embrace these sort of new architectures and new software patterns that developers are looking to do.
So part of that migration in terms of being able to deliver this constant pool of innovative and incremental innovation was the move and the shift to 6 months. One of the questions we have is, what was some of the challenges to move to the 6-month release cadence?
So someone asked that before going to my keynote, right?
That's right.
Okay. Well, there were a bunch. There were a bunch of technical challenges that we had. I didn't go into it in a whole lot of detail, but I can tell you that, the way that we had the code structured came from a time in the mid-90s. When I first joined the Java team, a big problem that we had was we were trying to make this really ambitious platform. It was pretty small to start out with, and a sort of problem that came from the solution was everyone wanted to contribute APIs, and we wanted the platform to be big and rich and have a library that was that had many of the things you needed. And a result of that was that we had a team that was growing, and we were also trying to deal with licensees from other companies. This is before we had a structure like OpenJDK in order to accept those kinds of contributions. And in fact, we were using, I'm trying to remember what we were using at the time. I think it was basically just SCCS, but there was sort of a internal to Sun advanced version of SCCS that was called Teamware or something. This was crazy, right? But it was sort of, how you did things at the time. And so basically what happened was each group was trying to move fast and get their APIs done, and so the code base was split into sort of a hierarchy where each group had their own repo, and these things were sort of painstakingly, kind of integrated together to make the whole. And what that meant was, it was fine at the time when the challenge was, how do you scale to hundreds of people from an organization of, I think it was 35 or so when I started. Basically, it let people get work done and not be interrupted by other people, checking in, breaking changes. Well, fast forward a little bit, where the problem, in say 2010 was no longer how does one group move fast to create something that doesn't exist yet. It was more, well, you need to make a change, but that change actually you want to be able to do across different ones of these repos, right? So a change in the language, you want to use it in the libraries, you might want VM support. And in order to do sort of single changes there, it could take weeks to get it done, simply by, needing to integrate, changes and have them permeate through all of this structure. So, that to give you an idea of kind of the level of technical challenge, there were some pretty basic things that we needed to do that hadn't been done, not because people didn't think they were a good idea, but just because, that was not the sort of pressing need at the time. And so deciding that we wanted to go in this direction of sort of more incremental, more rapid changes sort of made us think about what are the things that are causing friction in our process and what can we do to eliminate those. So there were a whole host of these kinds of things. We moved, for instance, we had actually, the sort of code repository had moved from SCCS and Teamware to Mercurial, and it had been on that for a while. One looking at that in, say, 2012 would say, why did you guys choose Mercurial? That was a really odd choice. But when it was actually chosen in around 2006, it was a really smart choice, because the other alternative wouldn't have been Git, it would have been Subversion. So there you go, that was fine. And then we did a lot of stuff to improve the testing, to rev the tests with the code. It had separately been in completely separate repos and versioned separately. There was a lot around automated build and test that we wanted to make better. And in a lot of ways, the need for that was actually driven by the kind of cultural change that I was talking about. So the way that developers typically thought about getting a feature in the past was, well, it's going to be about 2 years until this release comes out. I want to get my feature in early. It's kind of broken now, but there's plenty of time to fix bugs, right? Well, when you're releasing every 6 months, you kind of have to think about it the other way, right? The way that you want developers to think about it is, I'm not going to check my thing in until I'm absolutely sure it's ready, right? And ready doesn't just mean I've written the code. It doesn't just mean I've written the code in the tests. It means I've got a specification, because Java has a specification, and this needs to be in there. I need to have the TCK test for it. I need to have done performance testing. I need to test how it's interacting with all of the other features. And so basically, we needed to create infrastructure that allowed people to do all of this themselves before they were checking things in. So there was sort of a bunch of work there. And then, again, the final thing was this sort of cultural idea of thinking differently about, what are the ramifications if my thing doesn't come in now? No longer is it, well, if it doesn't come in now, no one's going to use it for 4 years. Instead, it was like, no, I'm going to get it out there. People are going to use it. It's not going to be the whole world yet, but a lot of people are. And I really need to make sure I'm not going to break the entire world.
So there's a really good, oh, please go ahead.
Yeah, I just wanted to add, I think the organizational aspects are super important and the infrastructure related things, but there's a second aspect to this, which is when you have a 6-month release cadence and you have a big feature, like a really big feature, it sort of forces you to think about not only what are the discrete pieces of this feature, but also in which order do they make most sense to try to integrate. And that's actually turned out to be a really beneficial thing, because a lot of subtleties can hide between those parts if you don't look. So that for me, that's been hugely beneficial.
I think a great sort of component to this question is also tied to the next one, which is, and I'll try to summarize because there's been several questions on this, which is the purpose of preview. Can you please go into detail on preview features? You want to take that one, George?
That's going to me? Okay,
Sure.
Yeah, so I sort of mentioned this morning, preview features was sort of an unexpected bonus that we got by moving to the 6-month cadence. And what I mean by that is this, that one of the things that was always very challenging for us in the old mode of working was getting feedback from people on features, right? So we've worked on something, typically, we have always had, well, we've at least since 2006, we've, and even before that with the JCP, had a pretty open, discussion about features we were working on. And it's been possible for, people to give feedback on them. But the feedback that we get really depends on how easy we make it for developers to pick something up and try it out and give us that feedback. And so one of the things that actually, that helped initially was when we went from the initial sort of the way we developed Java at Sun, where, there were commercial licensees that would pay to get access to source code and give us feedback and sometimes contribute things, to, the introduction of the JCP 25 years ago. That was just celebrated last 2 weeks ago. And that helped a little bit because now there was a more formal process for other companies and organizations and, open source foundations and so on to get involved and take part and give feedback and even help design, new features. But then a pretty big change happened when we announced OpenJDK and contributed the reference implementation that had previously been SunJDK. And so that meant that like developers now could sort of see a bunch more of what was going on and see the code. And because of the way that we do development in OpenJDK, it's not just like when it's done, we throw it over the wall. Right? It's the code is there. You can see every change. You can go and, subscribe to the mailing list where new features and designs are being discussed and their pros and cons. Having things like the JDK enhancement proposals, JEPs, in the Java bug system, where you can go and look at like a write-up of what is this intended to do? What's it not intended to do? What problems are we trying to solve? What ones aren't we? Are there security aspects? Are there performance aspects? What things have been thought about? How's it going to be tested? And so I think that's something that has really helped a lot. Coupled with the fact that, and not everyone knows this, but while we are developing the next release, we put out early access builds about every other week. So you've been able to download 22 for quite a while. Like basically since 21 came out. And you'll continue to be able to do that. And we encourage you to do that. And part of doing that is giving us, feedback and telling us about bugs. And, in the old days, I don't know how many of you were sort of working on big software projects back then, but a big problem you had was, well, we do alpha releases or beta releases. And then you put the beta release out. And by the time you get feedback from the beta release, the next beta is ready. Right, so it's like maybe you get the feedback from one beta in like beta +2, right? And that's kind of crazy. And one of the things that led to those cycles being so long. So putting out these early access builds, we've seen the sort of inflow of bug reports even out and be earlier, such that we actually have often a chance to fix things before they're even in that first state where they come out. And then the sort of final addition here has been preview. I think some people, get confused about preview and think, well, it's a beta feature. It's not a beta feature. So to be clear, like a preview feature is one that in the old days we would have shipped as final. It's fully designed, implemented, tested. We think it's rock solid. We think the specification is rock solid. It is specified. There are TCK tests. Like it's really literally like we would have said that it was final in the past. And what would have happened is, it would have been out there for a month or 2 or 4 months, and someone would have seen something that we missed, and they would have reported it to us, and we would have been like, oh, shoot, now the whole Java ecosystem has to live with this for the next 20 years. And instead, what previews let us do is put it in there in the release in a way that, you don't get it unless you turn it on. So the intent of that is not to make it hard to use, quite the opposite. It's to make sure that you're aware that you're using it, right? You don't accidentally start to use it and depend on it. It's different from incubator. I will say incubator features, some people, this is easy to get confused about, but an incubator feature is guaranteed to change. At the very, very least, the package name will probably change. But a preview feature is not. Like we've had ones where a preview feature, goes from one release to the next unchanged. But, ideally, often, most of the time, usually, we have gotten feedback and we've listened to that feedback and we've made the feature better and believe that in its final form, it's much better prepared to stand the test of time. Now, the flip side is, it might take another 6 months, might even take a year. On the other hand, we expect these features to live for much, much longer than that. I think it's kind of better for everyone that we've made them as good as they can be.
And I think another thing is that the preview can kind of transitively traverse down to third-party libraries. So, for example, Jetty, you can set a switch and it will use virtual threads, or another library can use the Panama API. And then you will see actually how your application will behave when this kind of feature is enabled. So I think that's a good thing too.
Yeah. So in line with that, I mean, the question that we get sometimes, and I realized I didn't address it, can we use them in production? You can. You can use them in production. We think they're production ready. However, if you use them in production, you just need to be aware that there's, a chance that there will be a change. Most of these have not seen massive changes. It doesn't mean you're gonna have to rewrite everything. But, you should just know that like that's something that you're saying effectively that you're prepared to do.
And I'll just add that we'd love to hear from you using them. Not only if it breaks something, but we'd love to hear that it worked in your use case and you loved it and you're excited for it. That actually helps us just as much as the other case. So you can contribute to the mailing list, or you can just tweet at us at Java, or really any of us up here, and it'll make its rounds around the team through our Slack and everything.
Yeah, and another thing that is important that might be overlooked is documentation. So when you're in preview, when something is unclear in the documentation, it's a perfect opportunity to give that feedback as well. So new features is always better if people understand and can use them effectively. So also a good thing to report back.
Yep, so there's a whole section of questions I'm about to start, but before we do that, one of the most important things is we're trying to minimize the shock on the system to all of you. And that's why we have preview features. That's why we have early access builds. That's why we have this open development model at OpenJDK. Oftentimes we'll get the question, where does the magic happen? What's the secret sauce? And the reality, there's nothing up our sleeves. We encourage you to come to OpenJDK, as George said, and see what we're doing. See our design decisions, what decisions we are making, more importantly, what decisions we're not making, and the rationale why, and allow you to participate in that discussion. It's inherent in this journey. As smart as we are only smarter with your participation. So you give us feedback, you play a role in the design and the future and the innovation and the pipeline of what we deliver in Java.
If I could just add one thing to that, the mailing lists, there's a lot of information. If you subscribe to the mailing list and you want to get the stream of information, that's amazing and awesome. And the discussions are very eventful and exciting most of the time. But if you don't want to subscribe to those, you can also go to inside.java, which is a website that we created to sort of pick and choose the gems that might be relevant to people who care about a particular topic, like Loom or Valhalla or paving the on-ramp or JDK 22. We kind of label it, and you can subscribe to all those different topics, and we can kind of feed you the things that we think are relevant.
Wait, did you say Java's a TLD?
Yeah, inside.java. We have two .java websites.
What's the other one?
Dev.java, which you've probably seen on the back of a lot of the shirts we've been wearing, and inside.java are the two that we have today.
Maybe you want to expand a little bit. What's dev.java?
I guess there's a question on that probably.
Yeah.
Dev.java is the place to go for everything Java related. So we have mostly like hundreds of tutorials written by the Java team at Oracle, but as well as community contributions from many community members as well, organized nicely by topic in a bunch of different work streams depending on your skill levels. We have information on all of our community programs. One of the questions I think I saw on a list was about the Java user group program. You can find information on the Java user group program at dev.java. There's a playground, so you can go to an online REPL and you can just sort of type in code, or you can drop down and select various new features. It'll populate it, click run, it'll compile it, and return the result right in front of you using the JShell API. So some pretty cool things at dev.java. And Inside Java is also a really good website that our team manages.
I'm just curious, just a show of hands, how many people are a member of a local Java user group? I need to fix this. We need to fix this. That's really your local resource in terms of where the discussions happen, where the experiences, the expertise, the best practices, the use cases get surfaced, so you have a stronger understanding where many of these features have applicability. So if you're not a member of a Java user group, as Chad said, please visit us at dev.java. We have organized and listed every Java user group on the planet that we know of. I don't think we have one in Antarctica yet. Maybe we can change that. But we encourage you to join. We have many speakers, oftentimes from Oracle, that come and speak. We also have luminaries such as yourself that are an extension of us, explaining how to use certain features both in development and in production. So we can talk about that in the booth later. Maybe we can have a drink, but great resource for all of you. What's that? There's a jug meeting. Oh, and there's a jug meeting tonight. So you have an opportunity to actually have a Java user group discussion today. So let's
7 p.m. where?
It happens here at the venue. I'm still waiting for the details.
Here at the venue.
Okay.
All right.
I'm going to try and do my best Steve Ballmer because this is an interesting question. AI, 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 AI. How many times? Oh, AI, AI. What is Java doing for AI? Who wants to take that question? Is that who's going to grab that one first?
I'll say something quick, and then you guys can say something real. How about that?
All right.
All right. So, so when people think about AI, there are a lot of different things they think about. I guess what I would say is this. I think that early on there was sort of this perception that if you're doing AI, Python's the only thing. And a lot of the reason for that is Python had some great APIs for putting a thin veneer over native code, and in almost all of those cases, there are a few exceptions, but a lot of what was actually happening was Python made it very convenient for you, at a high level to do something interactive with something that was pretty complex at a lower level. And so, one of the things we found was that, we felt that people were not doing this in Java in part because JNI is really horrible to use. Any JNI users out there? I'm sorry. Yeah, so, keep in mind, JNI, was a solution for another day. It was put together in the mid-90s when, part of the problem was they didn't want to write something that was so, delightful to use to call native code that no one ever wrote any Java code. Because there wasn't any at that point. It's true story. But we're at a different point now. You deserve a better interaction, a better experience when you're trying to call native code. There are lots of valid reasons for doing it, including calling, say, TensorFlow or something like that, right? And so that's what Panama was about. In part, not just for this use case, for many, but it is one of the big use cases that's helped there. The next thing was we looked at, okay, great. Well, why were those native libraries for AI written in, why were they written in C++ or something rather than Java? And a big, I think a big reason, we talked with the people who, and this was, several years ago, the precursor of, so you guys know this, right? Precursor of AI was kind of machine learning. What was before machine learning? Well, we called it big data, right? So in a lot of ways, right, where we've kind of come from is the problem that people were having with Java that made them, in some cases, look at writing native code and having their own sort of memory management was that they felt that in Java it worked, great for primitive types and sort of collections of data that was primitive. Objects are wonderful, but and they're super powerful, but there's some downsides. They didn't really get control over where they are, how they're laid out in the heap. In fact, the runtime is doing it for you and trying to do the best job. But it's, because of some of the guarantees that we have to provide, because of object identity and the ability to subclass and have polymorphism, right? All of this made it very, very difficult if what you were trying to do was represent a huge amount of pretty complex data. And that coupled with, garbage collection, at that times, let's say, 7, 8, 9 years ago, not being at a state where it scaled really, really well with massively large heaps, it's no wonder that people chose something else. So we thought we would go, start to set out about solving some of those challenges. And there were a few things that we did. Some of it was, the steps that you saw with, immutable data like records. This is going on into Valhalla. So I think Valhalla is something, as we're starting to see come out of that will help a lot there. And then, things like ZGC help tremendously as well. And so, interestingly, I think what we're going to see is that as you have things coming out of Valhalla, you're going to be able to represent, complex data in much more compact, memory-friendly ways, at the same time that the memory management from the garbage collection side is getting much, much better. And we're getting the idioms in language that allow you to, describe how you want to process and deal with that data in a way that feels a lot more natural. So, when I was talking about the sort of, holistic confluence of all of these things we've been working on, that's the sort of thing I was talking about.
So I think you said everything I wanted to say. But I want to just add that if you want to, for example, wrap a native library, we have an excellent tool called JExtract, which can automatically create bindings for you. So you can basically point it to some .h file and push a button, and there you have your API, and you can just use it directly from Java and bind everything from Java all the way down. Yes, the question there? A good question. So the question is, why didn't we include it in the JDK? And I think the answer is that it's kind of more of a tooling thing. So we don't want to burden the JDK as it is, because we want to, not everybody is using native bindings. It's just a small fraction. If I could just guess like this, it would be like less than 1%. So carrying that weight wouldn't make sense, in my opinion. So I think it's good that it's actually a standalone tool. And as we speak, we are doing a lot of things to improve JExtract, as we are now planning to release Panama in Java 22, which the first release candidate will be in 2 days, I think. So that's exciting.
I can't clap. Sorry. I don't know if I have that much to add, but I think the theme here, especially listening to George's explanation, is that we're a platform and we're trying to do what we can do and only we can do in the platform. And perhaps it's not really about implementing support for AI, but implementing something which facilitates efficient usage or efficient AI processing. So, and of course, the boundaries are a bit fussy here, right? But we don't know what kind of models and what kind of innovations in that space will happen over the next 10 years. But perhaps we can do things that will make those easier to come to fruition and be more usable. So, yeah.
I wanted to say thank you to my, I guess, co-presenter this morning, Lisa Ross. If you didn't see her keynote, go back and look at it. It was great. And one of the things that she's involved with is LangChain for J, which is a great package that can be used for LLMs in Java. And I think that is sort of an undertold story, that there are more people doing AI in Java than most of the world is really kind of aware of. And I think part of that is when something gets momentum, they know, like journalists know they can get clicks by writing about it, and so it sort of feeds on itself. And this was sort of like when cloud came out and everyone was like, like language, whatever, I'm not going to name one because there are several, is the language of the cloud. And then what it turned out is that like so many people are running Java in the cloud. It's just that it wasn't exciting to tell people that. Anyway, I think that's kind of cool. I think, I did have a great chat with her this morning about the kinds of things that we're trying to do to, as Victor said, make it so that Java is a platform that anyone doing AI wants to choose.
So sort of tied to this is also continuing on the AI thread. With Java 22, we have Vector API in its 7th incubator. When will it come out of incubator?
Yeah, I think that's the record, and I think next time in Java release we're going to break that record again, for sure, because we are waiting for Valhalla. So we need to kind of align the APIs, and because Valhalla is not there, we need to kind of keep it on ice, so to speak, for the moment. So I'm not expecting the Vector API to finalize anytime soon. So I think this will push us to the next question: when will Valhalla be released? And I'm happy to hand over the mic to some of you guys to tell us more about that.
Way to deflect.
When it's ready.
Well, I think it's ready when it's ready. And I think we want to see soon, we're going to see drops of things, kind of facilitators that we need as a stepping stone to kind of launch Valhalla. And we are going to progressively be capable of enjoying the fruits of the work that's been going on from Valhalla for, I think, 10 years or something. And I always say that Valhalla sounds easy, but it's like performing open heart surgery on a living patient in an ambulance, because compatibility was always very important for Java, but so much things need to change underneath. So it's a really tricky thing to do.
Bit of a pivot here. Maybe this is for you, Per. Will there be long indexed size collections?
I think there already are. If you use the Panama API, and we are working on something called record mapping. I mentioned in a previous, comment here that records are really a good thing to use together with the Panama foreign function API. So the FFM API have excellent means of working with primitive data, but it doesn't fit so well with composite data like records. But this will soon change. And when we have that kind of capability, it's very easy to roll your own, for example, list of some kind of record, and then you can have memory segments of arbitrary length, and then you can have a long indexed list, for example, or set or map or anything. But I don't think there's going to be an out-of-the-box solution, at least not anytime soon. But maybe there will be a third-party library that can do that.
Any you want to name?
Beg your pardon?
Any you want to name?
I don't know. It's just, it might pop up.
So we're getting a lot of questions on some of the active projects here in OpenJDK. One of them, of course, I think is creating quite a bit of density in terms of conversation is around Project Loom. We saw the workshop yesterday. But in terms of a couple of questions here, thank you for releasing the first feature out of Project Loom with virtual threads. What are some other Loom features on the horizon that you can talk about?
Yeah, no, so there is something called structured concurrency, which is like in the past we can just spin off threads and then you didn't know if they kind of were finished, but now you can structurally integrate a kind of a bouquet of threads in your code. So you know that when I'm entering this try with resource block, anything that is getting spawned inside that will be completed when we exit that block. So I think that is a good thing that will come out of Loom. And I think also we're going to see some kind of performance improvements like around monitors and things like that.
Yeah, I can just add as well, being able to design around some of the situations where we have to do pinning today. So we have to pin a native thread to continue on. So there is work being done in that space. So I think that's something that people might be interested in. But feature-wise, I think what Per meant before with the structured concurrence, it's a bit of a game changer when it comes to how you declare what you're going to do in a concurrent setting. And being able to reason about that when we exit this try with resources block, all the things that we spawned, they have completed, and those tasks are, or failed. They have completed in some way, shape, or form. But just knowing that after this point, this is what the state looks like. So looking for feedback there as well, always welcome, especially when it comes to developer experience in the API space. It's much harder to get feedback on the pinning, which is more like seeing threads being pinned here. But ergonomics is important too. So do give us feedback on structured concurrency if you have that use case somewhere.
Another smaller effort is like the replacement of thread locals, because now if you're suddenly spawning 1 million threads, then thread locals will not scale. So there is some work going on there. So you have a more specific life cycle, and I think that will coincide greatly with structured concurrency too.
Yes. So with the scoped values, which is called the replacement for thread locals, it's an interesting problem space, right? Because when you have tasks that are forking off, so you have a task that forks multiple tasks, and then joins, how do you reason about what they share in terms of local values that are propagated across these things, and what do you do when they're supposed to join? So very important feature for sure, and also one of those where feedback much welcome.
So we have a bit of a philosophical question. Thank you for whoever DM'd this. They didn't want their names public. That's fine. I will ask this anonymously, but it is, Java seems to adapt based on what other languages are doing. Could you please explain the rationale behind this?
Yeah, so I tried to cover that a little bit this morning as well. What I would say is this: I think that we look to a lot of different sources of inspiration for what are the things that we need to work on and what are the problems that we need to solve. And there are some that are some obvious sort of vectors of change in the industry, right? There's new hardware that comes out. And that doesn't just mean like a new chip, it might mean new sort of hardware designs, right? Like when hardware went to multi-core, you know, we needed to worry about, well, what does that mean and how can we help Java programmers take advantage of it, even with the existing code that they wrote years ago, right? By making the JVM better. Another one is software architecture. So, if everyone is writing code in a way that looks like, Java EE, that's sort of one pattern. And if everyone is deciding that, like, now we want to do microservices, it drives sort of different requirements from a platform like Java that we want to be sort of conscious of what can we do to help, or where might we be doing things that don't help. There are, other things like, containers, right? Like trying to make sure that things work smoothly in a world where the sort of the layer that is under us has changed somewhat radically, or sometimes subtly, but in ways that affect us and affect your programs. And so, there are that's sort of one set of things that we look at. Another one is really use cases, right? So I mentioned AI, and, even earlier we were looking at that as, a set of use cases that became AI, that were kind of driving the sorts of problems that we understood people wanted to use Java to solve, but maybe, it was not ideal in one way or another. And then, looking sort of orthogonally, and this was the question, like other languages, like, why are you looking at that? It looks like you're just reacting to what they're doing. So first of all, let me just say one thing. Anyone who thinks that they were doing something original doesn't realize that, like, they copied something that was in the 70s too. Right. So, so that's pretty clear. And it's like, sometimes people are like, you did this, and that was in this language over here. And we were like, it was also in that language in the 70s, right? This is, it's not super new. If you want to know sort of philosophically from the beginning, why did Java start out that way? I'll just, refer you, if you haven't seen it, go back and look. It holds up after all these years. There's a really, really great video with James Gosling from the mid-90s that was sort of talking about Java. I think there's actually a paper as well, right? So that basically, I think what you can Google for is Java, a blue collar language, right? And so, that sort of paper sort of explained that it's like, our aim is not to be, the first kid on the block with some new thing. It's really to bring advanced tools to a larger group of developers in a way that helps you solve real problems. And so being first doesn't, especially, when we have such a dedication to not breaking your stuff as you're going forward, it's not always really what you want, right? So there are always going to be people who are, telling you in your company, maybe they sit at the desk next to you, who are saying, oh, Java's no good because it doesn't have X, Y, Z, and like, this is so much better. I had somebody telling me this last night, and, this person was actually telling me about the place where she works, where, there were a few people, there were like one or two people who really wanted to use Clojure. And she said, and that's great. You can understand why. And maybe the particular problem they were doing made sense there. And by the way, nothing against Clojure. I love it, and I love the folks who make it. They're wonderful. But it's not necessarily the case that it's the right choice for everyone in a big audience. In fact, it isn't, because we don't see it making that transition. And so when we're thinking about Java and its evolution, we try to be really, really conscious of making responsible decisions, given the fact that the decisions we make affect such a large audience. And so often what you see is that languages that are newer or smaller can responsibly experiment with things that it just wouldn't be responsible for us to experiment with. But we can learn from how that went. And, we don't tend to learn from it by like just copying what someone else did. What we tend to try to do is to look at it and say, what approach did they try? What was good about that approach? What did people like about it? What didn't they like if they didn't like everything? And also, so what can we learn from that? But also, what can we learn about, how can we sort of interpret the sort of Java way of doing this thing? Because, languages do tend to have a particular feel. We like to think that Java has a feel, and we try to be true to that feel so that, when you get a new feature, it feels natural. It doesn't feel like some weird thing bolted on the side. I guess one sort of thing that I would mention, if this is a topic that you're really interested in, we have put on almost every year. We actually did it this year for the first time since the pandemic. And before that, we had done it every year. We put on a conference, a very, very small conference. It's called the JVM Language Summit. And that was originally put together in order to have people who implement languages on the JVM get together and talk about how can we make the JVM a better target for new languages. And in fact, it's sort of a who's who of programming language communities. There have been wonderful people who have come from all, probably your favorite language and spoken there, because the people who make languages, like they don't hate each other and think I don't like you because you work on this language. It's more like, oh wow, you're working on this cool language. You know, we saw when you did this. Tell us about it, and really be more open to exchange of ideas and learning. And those are, I think, pretty much all online
They are all online, available on our official
on the Java YouTube
Java YouTube channel, youtube.com
Yeah.
/
The most recent one was in August of 2023, and there are ones stretching back over the years. So go and check them out. It's a great resource.
Yeah, and if you have a challenge finding any of the resources that we've either discussed today or in your own environment, please stop by the booth. We'll walk you through it as best we can. This is a really good question to kind of wrap up on because all of us come from different backgrounds, different experiences, have different perspective. And so I'd like to surface this because this sort of hits true to why we are here as part of the Java community. And that is not a technical question, but what is your opinion in how to improve bridging the gap between junior and senior developers in the Java ecosystem? And so it's a bit broad, but each of you bring interesting perspective. And Chad, maybe you want to start with that because it's something sort of front and center for you almost every day.
Yeah, let's see how to start with that one. I would say the number one thing that I've observed is that being effective at your job as an engineer or developer is not necessarily a coding problem. It's a people problem and a communication challenge and a communication opportunity. Of course, programming is just like anything else. It's a skill that you want to practice and practice and practice over and over and over again and try and fail. It's like in my 20s when I was starting my first company, I was at that point in my life where I could stay up all night and just kind of work on side projects and keep pushing it forward. And I learned so much by failing. I felt like I was always failing. Everything was always breaking. Nothing ever worked. I'd spend 12 hours on a bug, and I don't know, there was no ChatGPT to ask at the time. I don't even think there was Google at some point in that history. But anyways, just doing it a lot. But number two is find mentors and observe how really well-respected senior developers operate. Just observe how they communicate with others. Observe how they ask questions. Observe how they treat others. Because those are things that are extremely important to being able to communicate ideas and to build as a team. I watched as I've built some engineering teams at my companies, and you always get those developers who really struggle with communication, and it almost never works out, no matter how great of a developer they are, because developing software is a team effort. And so that was one thing that we really tried to encourage at our company, is to learn from each other and observe from those who are, have a level of maturity where they can now sort of respect others, ask questions, not kind of demand things.
Thank you.
I'll start there.
That's a great summary there. The only thing that I would like to add is, personally, my approach has been to always be on the lookout for the things that I don't know. And if you have that and you ask people, what am I not seeing here? What have I not thought about here? You learn new things at a deeper level of how do I approach things. And I think it is a process, and you have to be surrounded with people that can bring you along on this journey, because otherwise you will have to discover everything on your own, and that's a long journey. And we're sort of, as software developers, we spend a lot of time being told we're wrong, right? The compiler tells us we're wrong, the tests tell us that we're wrong, right? So there is an underlying tenacity in just trying to get it right. So if you have the drive of wanting to solve something, and you're asking the right questions, I think that goes a long way, presuming also that you have support around you.
So I'd like to say in closing, kind of on this topic, is my father, who's been in tech since 1962, 61, when we heard the phrase, move fast and build things, he pivoted in a dinner conversation and said, Shar, move thoughtfully and build things. And I think it's an important sort of approach to that statement, which is when we move thoughtfully, it doesn't mean things won't break. It means we're trying to reduce the footprint of when things might break. So, here in the Java world, we want to create things that are long lasting, and that takes thought. that takes open, transparent communications. It's a philosophy that we communicate to the community, but it is inherent in our guiding principles here on the Java team in terms of trust, innovation, and predictability. We live by those principles every day, and we will continue to live by those principles. And so, in closing, we just want to say thank you. I would ask you, if you can, if you're on, is it X, Twitter? Twixter, please follow this amazing talent that's on stage. We want to keep the conversation and dialogue going. Please ask us additional questions, but more importantly, please stop by the booth. And lastly, we thank you for your participation in the Java community. So thank you.